Good morning. Today we're going to talk about an exclusive kit called Dual Kit to analyse both plasma and urinary catecholamines. Before continuing, I want to remind you of last week's video in which we have spoken of urinary catecholamines and their importance of their analysis for the identification of some adrenal medullary tumours, shown the advantages of the fluorometric over the electrochemical detector, shown how to perform the analysis of urinary catecholamines in HPLC with the Eureka kit, which involves the use of an extraction resin without using SPE columns, highlighted the speed of the analysis. If you've not yet seen it, you can do so by clicking on this link. I would also like to quickly summarize the advantages that you can exploit in the laboratory using a fluorometer. The short time necessary for the stabilization of the signal, because the column and the fluorometric detector are conditioned in 15 minutes, and you can start the analysis immediately. The absence of daily maintenance, because the fluorometer has a cell that is cleaned only in extreme cases. The sensitivity of the fluorometer is 50 times higher than the amperemeter. The reduction of the operator's working time thanks to the use of purification resin. The derivatized norepinephrine is not affected by the interferer that can appear with the amperemetric method. We obtained a result every 5 minutes, and we have the possibility to analyze and report on a sample by midday. The cost of the fluorometric detector is more competitive. Having finished this brief recap of the last video, we are ready to present the Dual Kit that has been engineered for all those clinical laboratories that have to perform dosages of both urine and plasma matrices. Laboratories analyze plasma catecholamines less frequently than urinary ones. The use of the exclusive Dual Kit avoids the need of maintaining two analytical solutions. What do you need for this analysis? Isocratic HPLC equipped with fluorometric detector, ready-to-use kit complete with lyophilized calibrator, lyophilized controls, HPLC grade water, pipettes and micropipettes with various volumes, tips, plastic tubes, reduced volume vials with caps, a vortex, litmus paper or pH meters with electrode, 24-hour urinary samples appropriately acidified with indication of diuresis and EDTA plasma sample as anticoagulant, installation and conditioning of the chromatographic column according to the specifications given by the manufacturer. Let's take as an example an analytical session of 7 urine samples and 7 plasma samples on which to perform the catecholamine dosage. Together with these samples, we will also analyze one lyophilized calibrator with a known concentration that will be used to automatically plot on the software the calibration curve, and 2 lyophilized controls of level 1 and 2 that will be used to check the accuracy of the calibration curve and therefore of the whole analytical session. First of all, we will prepare the HPLC. The instrument must be cleaned from the previous analysis. We connect the clean analytical column to the system. Insert the floater into the mobile phase reagent M and let the pump flow at 1.0 milliliters per minute for 15 minutes. After this, we will be ready to make the first injection. With analytical systems connected to an amperemetric detector, this would not be possible. The times would be much longer, and this would create constant and daily inefficiencies in the laboratory. Let's move on to the workbench and reconstitute the calibrator and the lyophilized controls. We prepare as many 10 milliliter plastic tubes as samples, the calibration standard and the controls. We place the SPE column in the plastic tubes in order to collect the eluates to be discarded. Activate the SPE column by pouring into the column 1 milliliter of reagent A, conditioning solution 1, and let it percolate through the column at a flow of 1 milliliter per minute, drop by drop. Now pour 1 milliliter of reagent B, conditioning solution 1, into the columns and let the solution flow through the column at a flow rate of 1 milliliter per minute, drop by drop. Finally, pour 1 milliliter of reagent C, conditioning solution 1, into the columns and let the solution flow through the column at a flow rate of 1 milliliter per minute, drop by drop. In this phase of conditioning of the SPE column, it is very important to be careful not to dry the resin. This step is essential for proper extraction. The conditioning phases are common to both purification procedures. We are now going to differentiate the preparations of the two matrices, first the plasma, then the urine. In the case of sample preparations of the plasma catecholamine dosage, we prepare as many 10 milliliter clean plastic tubes as samples, including calibration standard and controls. Now we dispense in sequence in all the tubes 1400 microliters of reagent D diluting solution, only 600 microliters of calibrator samples and controls, 100 microliters of reagent I internal standard solution, diluted 1 to 10 with HPLC grade H2O. Then place in a vortex for 5 seconds. Now we add to the SPE column, already conditioned in 2 consecutive pipettes of 1 milliliter, the calibrator, the samples and the controls prepared in the previous step. Let it slowly percolate to the flow of about 1 milliliter per minute. In this passage, the liquid must pass through the column very slowly to make the molecules of interest interact with the resin and remain connected. At this point, we wash the SPE column, adding 1 milliliter of reagent E washing solution, and repeat this operation twice. We conclude this operation by drying the resin with a light flow of air. These 2 washes allow us to eliminate all interfering substances. Now we move on to the elution and collection of catecholamines from the SPE columns. Place the SPE column inside clean collection tubes. Add 400 microliters of reagent F to each SPE column, taking care to collect the eluate. The elution takes place slowly for about 1 minute. Also, this step, like that of the sample load, must take place very slowly to favor the elution of the molecules of interest. Then the eluate is vortexed for 5 seconds. The next phase involves the derivatization of catecholamines. Pipette sequentially into a 1.5 milliliter reduced volume glass vial with stopper, 400 microliters of eluate, 20 microliters of reagent J derivatization solution, 20 microliters of reagent L starter solution. Activate the vortex for 5 seconds. We incubate our samples for 15 minutes at 70 degrees Celsius. Let them cool at room temperature. The sample thus prepared is stable for 7 days at 2 to 8 degrees Celsius, unlike the eluate used with the amperometric method, which is usually stable for about 24 hours. We are therefore ready to perform the injection of the entire analytical section of plasma catecholamines. Move to the HPLC system and activate the method Eureka Kit plasma catecholamines so that the system sets itself to the correct parameters. The instrument on which we perform these tests is an HPLC 1260. but the method can be applied to any isocratic HPLC equipped with a fluorometric detector. Following this, we place the vials in the auto-sampler tray starting from the calibrator, continuing with the controls and samples, and starting the sequence. The chromatographic runtime is 5 minutes, and for our sequence of 7 samples, all results will be obtained after 50 minutes of instrument work, including the injections of the calibrator and the 2 controls. This is a typical chromatogram of the plasma calibrator where the peak of noradrenaline comes out at 1.41 minutes, the internal standard at 1.91 minutes, while the peak of the adrenaline at 3.04 minutes. Finally, the dopamine at 4.31 minutes. This is the typical chromatogram of the level 2 control, where you can see that the peak of the noradrenaline comes out at 1.41 minutes, the internal standard at 1.92 minutes, while the peak of the adrenaline at 3.05 minutes. Finally, the dopamine comes out at 4.32 minutes.